In an age where you can zoom into almost any corner of Earth on your phone, you'd think we'd found every mountain by now. But you'd be wrong. In the last 15 years, scientists have discovered dozens of mountains that nobody knew existed. Some were sealed beneath Antarctic ice sheets. Others sat obscured by clouds or poor mapping, and a few were spotted by researchers casually scrolling through Google Earth. Today, we're counting down 10 of the most recently discovered mountains on Earth, all found since 2010. From submarine peaks rising from the ocean floor to Antarctic giants buried under ice sheets, these discoveries prove that even in the satellite era, Earth still has secrets to reveal. Before we begin, if you enjoy learning about Earth's mysteries and unexplored places, make sure to hit that subscribe button. We're constantly uncovering fascinating stories about our planet that most people have never heard. Now, let's dive into these incredible mountains. In 2011, a British Antarctic survey team conducting routine ice-penetrating radar surveys uncovered a massive mountain completely hidden beneath West Antarctica's ice sheet. Mount Hope rises approximately 1,400 meters from the bedrock, but sits under roughly 2 kilometers of ice. It has been buried for millions of years, completely invisible from the surface. To put that in perspective, the ice layer above this mountain is thick enough to submerge 10 Empire State Buildings stacked on top of each other. The find came during Operation Icebridge, a NASA mission using aircraft equipped with sophisticated radar systems. The radar works by sending electromagnetic pulses through the ice, which bounce back when they hit rock. By analyzing the return signals, scientists can create detailed three-dimensional maps of what lies beneath. They found evidence of neighboring peaks, valleys, and what might have once been river systems carved into the bedrock before the ice sheets arrived. Understanding this hidden topography proved crucial for modeling how ice sheets might respond to climate change. The shape and size of mountains beneath the ice influence how glaciers flow, where ice streams form, and how quickly ice might slide toward the ocean. This makes Mount Hope a key piece in the puzzle of Antarctica's future, even though it exists only as data and computer models. In 2010, Australian mountaineer Damien Gildia made a stunning revelation about one of the world's most famous mountains. Thousands of climbers had never actually reached the true summit. Puncak Jaya in Papua, Indonesia, is widely known as the highest peak in Oceania at 4,884 meters. It's one of the 7 summits, the highest peaks on each continent that elite climbers aspire to conquer. But Gildia's GPS measurements revealed that the true highest point wasn't the main summit at all. It was a smaller rock outcrop about 50 meters away that had been largely ignored. For decades, mountaineers had been stopping just short of the actual apex by a few meters. They had taken their summit photos and celebrated their achievement, unaware they had missed the genuine high point. The confusion arose because the mountain's glaciers had been retreating rapidly, losing approximately 80% of their ice mass since the 1930s. As ice melted, it exposed rock that was slightly higher than the traditional summit point. What had been buried under glacial ice was now revealed as the true peak. At current rates, the mountain will be completely ice-free within decades. Gildia's work highlighted a broader issue. Many of the world's high peaks had been measured decades ago using less accurate technology. Colonial-era surveys often relied on triangulation from distant viewpoints. Even modern topographic maps sometimes contained errors of 10 or 20 meters in elevation, a stark reminder of how our planet is changing and how the mountains we thought we knew are literally being reshaped. Number 8. Tamu Massif, Pacific Ocean. In 2013, scientists announced one of the most remarkable geological finds in decades, the largest single volcano on Earth, and one that had been overlooked for over a century. Tamu Massif, located about 1,600 kilometers east of Japan, had been known to exist for years. Oceanographers had detected a massive underwater plateau since the 1960s, but researchers didn't realize what it actually was until geologist William Sager analyzed seismic data and rock samples collected from the formation. What they found was staggering. A single massive shield volcano covering about 310,000 square kilometers, roughly the size of New Mexico or the entire British Isles. That makes it comparable to Olympus Mons on Mars, previously thought to be the largest volcano in our solar system. The peak rises about 4,460 meters from the ocean floor, though its summit still sits about 2,000 meters below sea level. If you could drain the Pacific Ocean, Tamu Massif would tower over the surrounding seafloor like a massive dome, its slopes extending for hundreds of kilometers in every direction. Scientists had assumed the formation was created by multiple volcanoes clustered together. The sheer size made it seem impossible for a single volcanic vent to produce so much material. Only after analyzing magnetic patterns in rocks retrieved from the seafloor did Sagar's team realize it was actually a single enormous structure. The volcano formed approximately 145 million years ago during the early Cretaceous period, when dinosaurs roamed the Earth. This revelation changed our understanding of how large volcanic structures can grow. Volcanologists had believed there were physical limits to how big a single volcano could become. Tamu Massif proved that under the right conditions, volcanoes can grow far larger than anyone imagined. In 2012, subglacial surveys revealed the true shape of Mount Sipil, an ice-covered volcano in Antarctica that had been seen but never truly known for over 70 years. Mount Sipil had been spotted from the air in the 1940s during one of Admiral Byrd's Antarctic expeditions. Pilots saw the volcano's summit poking through the ice sheet, a dark, rocky peak rising to 3,110 meters on Sipil Island off the coast of West Antarctica. They photographed it, marked it on their maps, and moved on. But the mountain's actual topography, the shape of its slopes beneath the ice, the structure of its base, all of that remained a mystery for 7 decades. The 2012 mapping exposed a massive shield volcano with a summit caldera several kilometers wide, multiple vents arranged in a rough circle, and lava flows extending over 20 kilometers from the central crater. The caldera itself appears to have formed through multiple collapse events, suggesting a long and complex eruptive history. Temperature sensors placed in boreholes have measured heat flow significantly higher than surrounding areas. Whether this indicates a still active magma chamber remains unknown. The possibility of an active volcano beneath Antarctic ice is both fascinating and concerning. If Mount Sipil were to erupt, the heat could melt enormous volumes of ice, potentially destabilizing the surrounding ice sheet. But Mount Sipil isn't alone. Subglacial surveys have now identified over 130 volcanoes beneath the West Antarctic ice sheet, many of them previously unknown. Antarctica, once thought geologically dead, appears to be one of the most volcanically active regions on Earth, and we just can't see most of it because it's buried under ice. In 2010, conservationists working in Sierra del Divisor National Park in eastern Peru confirmed details about an extraordinary mountain largely unknown to science, a near-perfect pyramid rising from the heart of the Amazon rainforest. Cerro El Cono is an almost perfect pyramid rising about 700 meters above the Amazon rainforest. While local indigenous communities had always known about it, the mountain appears in their oral histories and traditional stories. The peak didn't appear on most maps until recently. It existed in a cartographic blind spot, too remote for ground surveys and too obscured by clouds for clear satellite imaging. Scientific documentation came through satellite imagery and Google Earth. Researchers noticed an unusual, perfectly conical formation rising from otherwise flat jungle. Its shape was so regular that some initially speculated it might be artificial, perhaps an ancient pyramid built by an unknown civilization, later reclaimed by the jungle. Geological surveys confirmed it is natural, likely volcanic in origin, or shaped by millions of years of erosion into either a volcanic plug or a resistant rock formation that wore down more slowly than its surroundings. The mountain sits in territory inhabited by uncontacted indigenous groups, and Peru treats the region as highly protected. Unauthorized entry is forbidden, and no confirmed ascent exists in mountaineering records. The slopes are steep, overgrown with dense rainforest vegetation, and unstable. The indigenous peoples who live near the mountain surely know more about it than any scientist. Their traditional knowledge, accumulated over countless generations, includes information about the mountain's weather patterns, its role in local ecology, and possibly even routes to reach its summit. But that knowledge remains with them, protected by the same isolation that shields their way of life. Peru's decision to strictly protect this region reflects a growing recognition that some places should remain unexplored, at least by outsiders. Cerro El Cono will likely remain undocumented by science for decades or possibly forever, visible but untouchable. Number 5. Undersea mountains, global ocean floors. Between 2010 and 2014, oceanographers using improved satellite altimetry identified approximately 15,000 previously unknown undersea mountains across the world's ocean floors, effectively doubling our knowledge of submarine topography in just 4 years. These weren't small features. Many rise over 1,500 meters from the seafloor. Some approach 4,000 meters in height, dwarfing most peaks in major mountain ranges, yet they remain completely unknown because they sit entirely underwater, their summits still hundreds or thousands of meters below the ocean surface. The finds came from researchers at Scripps Institution of Oceanography who analyzed data from ESA Cryosat-2 and NASA JASON-1 satellites. These satellites detect tiny variations in the ocean surface caused by the gravitational pull of mountains on the seafloor. Even a few centimeters of water displacement, measured from hundreds of kilometers above, can reveal a massive submerged peak. This gravity-based technique is the only way to map the ocean floor at scale, unlike Mars, whose surface can be directly imaged from orbit, while Earth's oceans block most remote sensing methods. Lead researcher David Sandwell's 2014 findings showed that previous ocean floor maps had missed thousands of seamounts. Areas thought to be relatively flat seafloor turned out to be rugged mountain ranges. These mountains affect ocean currents, create unique ecosystems, and influence marine biodiversity. When deep ocean currents encounter a seamount, they're forced upward, bringing nutrient-rich water from the depths toward the surface. This upwelling creates oases of life in the deep ocean, supporting unique ecosystems found nowhere else on Earth. Many seamounts host rare deep-sea creatures found only on that particular mountain, species that evolved independently, producing unique variants. Even with these new findings, our knowledge remains incomplete. The satellite technique can only detect features larger than about 5 kilometers across. Scientists estimate there might be 100,000 or more seamounts that haven't been precisely located or mapped. In 2013, Russian researchers identified a previously unknown mountain during drilling operations near Vostok Station, and this mountain might be one of the most inaccessible peaks on Earth, sealed in a world of perpetual darkness. This peak rises approximately 1,200 meters from the bedrock beneath Vostok subglacial lake, one of Antarctica's largest hidden lakes. It sits entirely submerged beneath the lake water, which itself lies under about 4,000 meters of solid ice. The discovery was almost accidental. The Russian team was focused on reaching the lake water to analyze it for signs of ancient microbial life. Their radar revealed an entire mountain they hadn't known existed. Vostok subglacial lake has been isolated from the surface for potentially 15 million years. The lake contains liquid water despite temperatures far below freezing because geothermal heat and immense pressure from the overlying ice prevent freezing. Scientists believe the lake might harbor ancient microbial life, organisms that have been evolving in isolation since long before humans walked the Earth. If life exists in Vostok's waters, it could provide insights into how life might survive on ice-covered moons like Jupiter's Europa or Saturn's Enceladus, which are thought to have similar subglacial oceans. The mountain likely influences circulation patterns within the lake. If hydrothermal vents exist on its slopes, they would create localized warm spots, potential oases for life in the cold, dark water. Vostok Station, located directly above the lake, is one of the most inhospitable research stations on Earth. It holds the record for the coldest temperature ever recorded on Earth's surface, minus 89.2 degrees Celsius, measured in July 1983. Russian scientists have been drilling through the ice for decades. In February 2012, they finally reached the lake water after more than 30 years of effort. The initial samples proved contaminated with drilling fluid. but the discovery of the mountain opened new questions about what might be living in this ancient lake and how this submerged peak shapes the hidden ecosystem beneath the ice. Number 3. Puncak Jaya Revision Papua. In 2013, surveyor Damian Gildea, the same mountaineer who revealed the truth about Puncak Jaya, discovered something even more significant in Papua's mountains. It was the Puncak Jaya situation all over again, but this time the error wasn't just a few meters, it was an entirely unmapped summit. A different peak in the area, previously unnamed and unrecognized, was actually taller than the traditional Puncak Jaya that climbers had been ascending for decades. As with Puncak Jaya, the persistent cloud cover and political isolation of Papua meant that accurate mapping remained nearly impossible. The original colonial-era surveys had been recorded in official documents, cited by guidebooks, referenced by maps, and used by climbers, creating a circular validation that persisted for generations. The technology Gildea used, differential GPS, provides accuracy within a few centimeters when properly deployed. He would establish a base station at a known location, then carry a rover unit to the summit, comparing signals from multiple satellites to determine elevation with far greater precision than traditional surveying methods. Indonesia has since launched efforts to resurvey its highest peaks using modern technology, but progress is slow, and Papua's mountains remain among the least accurately documented on Earth. Mount Lico Forest, Mozambique. In 2012, British scientist Julian Bayliss was scanning satellite imagery of northern Mozambique on Google Earth when he noticed something extraordinary: a patch of dark green forest sitting on top of a flat mountain completely surrounded by vertical cliffs. Mount Lico rises to about 1,100 meters. Satellite images showed a circular plateau covered in pristine rainforest, isolated by cliffs up to 700 meters high. The mountain looked like something from a fantasy novel, a tabletop mountain with vertical walls, its summit completely cut off from the surrounding landscape. Bayliss realized this was likely an isolated ecosystem that might harbor species found nowhere else on Earth. Getting permission, organizing a team, and arranging logistics took 6 years. In 2018, a team of 28 scientists and climbers finally reached the summit by scaling a 125-meter vertical rock face using fixed ropes. The forest had been isolated for potentially centuries or longer. The team identified new species during their brief survey: a previously unknown butterfly, several endemic plant species, and rare orchids. Most surprisingly, they found ancient pottery fragments suggesting people had reached the summit in the distant past, using techniques now lost. During their week on the summit, the team worked frantically to document as much as possible. They set camera traps, collected plant specimens, and mapped the plateau. They discovered that water drains underground through cave systems in the limestone bedrock before emerging at springs around the mountain's base. Bayliss had literally uncovered an isolated mountain ecosystem by casually browsing satellite images. His discovery proved that significant ecological features can hide in plain sight, visible from space but unknown to science because nobody thought to look carefully at that particular spot. The summit forest is now protected, and access is restricted to scientific expeditions. Mount Lico represents a new kind of discovery, not a mountain that was physically unknown, but one whose significance was unrecognized until someone noticed it on digital imagery and decided to investigate. Between 2008 and 2013, an international team completed the most comprehensive survey ever of Antarctica's Gamburtsev Mountains, and what they found challenged our understanding of how mountains age and survive. The Gamburtsev Range had been spotted in 1958 by Soviet expeditions during the International Geophysical Year. Russian scientists driving tractor trains across central East Antarctica detected mountains beneath the ice with basic instruments. They recorded the finding, named the range after Soviet geophysicist Grigory Gamburtsev, and moved on. But for 50 years, scientists knew the range existed while having almost no information about it. In 2008, researchers launched a comprehensive mapping campaign using aircraft equipped with ice-penetrating sensors. The project involved teams from 8 countries and cost millions of dollars. Specially modified aircraft flew in careful grid patterns over the buried range, their instruments probing through the ice to map the bedrock beneath. What they uncovered was astounding. a range comparable to the European Alps in scale, with peaks reaching about 2,700 meters from the bedrock base and spanning approximately 1,200 kilometers. If you could remove all the ice, you'd see sharp peaks, deep valleys, and complex structures rivaling any range currently exposed on Earth's surface. The mapping revealed a geological mystery. The team found sharp ridges and steep valley walls, features that should have been worn down by erosion if the mountains were truly ancient. They discovered deep U-shaped valleys characteristic of glacial erosion and what appeared to be cirques on the flanks of the highest peaks. This created a paradox. How could glaciers carve valleys into the mountains if those same glaciers then protected the mountains from further erosion? The leading theory suggests the mountains were almost completely worn down by erosion hundreds of millions of years ago, then experienced renewed uplift much more recently, perhaps only 100 million years ago. When the ice came 34 million years ago, it preserved this relatively fresh topography. While the bedrock itself is over 500 million years old, the peaks appear as if they've been frozen in time, protected from erosion by the very ice that hides them. The surveys also revealed that the Gamburtsevs affect how ice flows across central Antarctica, creating zones of slow-moving ice and regions where ice accumulates. Understanding this topography is crucial for modeling how the Antarctic ice sheet might respond to future climate change. Similar to Lake Vostok, researchers found evidence of liquid water trapped in the valleys between these peaks, kept liquid by intense pressure and geothermal heat. Could life exist in these subglacial environments? The complete mapping represents one of the most significant finds in polar geography in the 21st century. Here was a mountain range sitting on Earth the entire time humans have existed, yet we only developed detailed knowledge of it in the last 15 years. The Gamburtsevs remain perfectly preserved beneath their ice cover, a geological time capsule waiting for future generations who might one day develop the technology to witness what no human eyes have ever seen. These discoveries continue. Improved satellite technology and AI-assisted pattern recognition are helping researchers identify features in remote areas that have always been there but never recognized. The ocean floor remains Earth's least explored realm, with vast areas still poorly surveyed. Antarctica's ice conceals an entire continent's worth of topography yet to be fully mapped. The age of exploration isn't over. It's just moved underground, underwater, and into the data. Each discovery reminds us that despite all our technology, our understanding of Earth's geography remains incomplete. Which revelation surprised you most? Let me know in the comments. And if you enjoyed this deep dive, make sure to subscribe. There's so much more to discover. Thanks for watching. And remember, somewhere out there, there's a mountain that nobody knows exists yet, waiting to reveal Earth's next secret.